Darn. Okay. So if you were taking my class, I would make you, and I was going to write the test. I would tell you that I'm going to give you this schematic on the test, and you're going to tell me all about it. We'll say that this is 28 volt DC bus bar, and that over here, and we're going to be simple about it. Keep this reasonably simple. All right, so here's a very, very basic schematic of the electrical system of the majority of small aircraft, airplanes, and small helicopters in the United States, across the world for that matter. The bus bar, through that round gizmo with an arrow, is hooked up to what side of the battery? The positive side of the battery. So if somebody drew the battery symbol, which is a long, short, a long, and a short, the side with the long lines is the positive side, and the side with the short line is the negative side. And of course, the negative side of the battery is always connected to ground. So what is the ground? Can anybody tell me what the ground is? And don't say the dirt and the sand. What? The what? The frame. Yeah, on a car, you might call it the chassis, and most of it's made out of iron and steel. On airplanes and helicopters, the chassis is usually made out of aluminum. Okay, does aluminum conduct electricity pretty well? Yeah. Does iron on a car chassis conduct aluminum pretty well? Yes, it does. So when you see this ground symbol down here, effectively that's negative side of the battery. And if you look at an automobile or an airplane, you're going to find the negative side of the battery. That's the black side. It has a really short cable. Usually it's only about a foot long, and it goes straight to the car. Even in an airplane, it goes straight to the airframe. And now this ground effectively means that everything connected to ground is all connected to the battery. So literally, this is a light bulb or a lamp. This light bulb, one side of it is electrically all the time connected to the negative side of the battery. Same thing for this motor. One side of this motor is always electrically connected to the negative side of the battery. So the way we turn things on and off is by connecting. If this side is connected to the negative side of the battery, then this side of the motor, it needs to get connected to the positive side of the battery. So if I close this switch and turn it into the on position, then that means electrons can leave the negative side of the battery, go through the motor, through the switch, through the circuit breaker, through the 28 volt bus bar, through this round gizmo to the positive side of the battery. So that's the way the electrons go. Dun, 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 dun. So that's the way electrons go. They leave the negative side of the battery and they go through ground. And in this case, they're going to go through the motor. They're going to go through the on switch, through the circuit breaker. And so this is the way the electrons are going to work while the battery is discharging. This red lines right here is based on you turn on the electrical master switch, but you haven't started and you haven't turned the alternator on yet, or the generator. So the battery is slowly discharging. So let's just say for fun, and I'm leaving out relays and some other stuff in here to make it simple, but if this was the starter motor, does that take a lot of electrical power or a little bit of electrical power? relative to most things on the aircraft? The starter motors take a lot or a little? A lot. Okay, so when we run the starter motor, let's say the engine doesn't start very easily, so we're cranking it, run, 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 run. Run, 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 run. Okay, so are we draining a lot of power out of this battery? Yeah, we're draining a lot of power out of the battery, but this is the direction it goes. Now, once we get the engine started, if the alternator is turned on, and I didn't draw a switch for the alternator, but once the engine gets started, well, let's go back. This is a 28 bus. What's the voltage of this battery if it's brand new and fully charged and it's 80 degrees Fahrenheit? What's the voltage on this battery? And we haven't charged it for at least an hour. Nothing's connected to it yet. It's brand new, fully charged, 80 degrees Fahrenheit. It's really close to what? 25.2. All right. Now, the only way we can charge this battery after it gets partially discharged, or even when it's almost, in any case, the only way we can charge the battery is to have something hooked up to it that is a higher voltage. The way I think about it is that when this battery discharges, this negative side of the battery has too many electrons and they're all negatively charged, and the positive side of the battery doesn't have enough electrons. And if you don't have enough electrons, you're positively charged. So as soon as we turn on this motor or a light or whatever it is, this electron right here travels in this direction and it comes around to this side of the battery. But when an electron gets to a place where it's positively charged, it gets neutralized. So we used up an electron. I want to let me stay there. So we used up an electron. So now another electron, this one goes through the motor, it goes to the positive side of the battery, the electron's not here anymore, and it goes where there's not enough electrons. So literally, as the battery is discharged, we have less extra electrons on the negative side, and since they went around and stuck themselves to where there was not enough, it neutralizes that spot of the battery. There's not any place in the battery that's pulling or attracting the battery. Remember, just like magnetism, north and south attract. In electricity, negative electrons are attracted to where there's not enough electrons, that is where it's positively charged. Opposites attract. So that's how come the battery is working, or will push electrons through, in this case through the motor, is the negative electrons are trying to get to the positive side of the battery. So what I want you to notice here is this motor, the direction of electrons going through it. I'm going to draw a big fat arrow. Here's the direction of electrons going through this motor. So let's say again, we haven't started the engine yet, but we close the switch and we turn this light on. We close the switch, so this is now in the ON position, and now electrons can also leave the battery. Electrons can leave the battery, and they can go through the light, through the on switch, through the bus bar, and they can also discharge the battery. So next to this light bulb here, I'm going to draw a big fat, another couple of arrows here. Here's the direction of electron flow. You probably don't remember from the beginning of the semester. Direct current is where the electrons only go in one direction. Alternating current, electrons go in one direction for a short period of time, then they go in the other direction. They stop, they go in the other direction, they stop, they go in the other direction, and they stop. And in airplanes, they do 400 of these cycles a second. Out of the wall is only 60 times a second. But we're not going to talk about alternating current anymore. We're just going to talk about DC systems, because the battery is a DC device in that when it discharges, electrons only come out of it one way. Another way to put it is batteries, when they're providing the power, electrons only come out of the negative side and they only go to the positive side, period, when the battery is providing the power. So now comes the fun part. Well, what happens when we start the engine and the alternator or generator is turned on? Who's providing, what component is providing the power then? So it becomes a bit different. Let's try a nice funny blue color. So let's say that we turn the alternator to on. In a 28 volt system that has a 25.2 volt battery, the voltage regulator is going to tell the alternator, put out enough amps to bring the voltage up to what voltage? Anybody that's not in their fourth semester, you have a moderate reason not to know the answer. If you're in your last semester, then that becomes rather interesting. Anybody else? Any human in the room besides me? I know the answer. No, try again. What? One more time? 28 volts. Yeah, I would. Mr. Zilke likes 28 volts. I would have said 28, 27 to 28, but I'm going to stick with what he says. 28 volts. 28 volts. I know this is going to be hard. Which is bigger, 25.2 or 28? I know that's really tough. The 28 volts is bigger. Now, this is the negative side of the alternator, and this is the positive side of the alternator. That is great. Okay, positive side goes through this gizmo. We'll get to it in a second, to the bus bar. And, of course, the bus bar is on the positive side of the battery, so that's good. But once you hook up something to a battery to charge it, you have to hook up something that has a higher voltage. And literally, I mean this literally, and we're going to get to this far side on the right here in a minute, but when this alternator is working and it's charging the battery, remember, when this battery discharged, the electrons had come down here and neutralized it. The alternator is literally going to suck an electron off of the battery, and it's going to shove an electron into the negative side. So it's going to shove an electron because it sucked one off of this side. It's going to suck another one off of this side, and it's going to pull it into the alternator and push it to the negative side. So it's going to recharge the battery. And you're going, hey, wait a minute, Mr. Johnson. You told me that batteries are in DC systems, and DC systems only have the electrons traveling in one direction. And that's correct, except under this one circumstance, is when the battery's getting charged by the alternator or generator. If you look, and that's only impacting the battery. You need to also understand this. This 28 volts is a higher voltage than the battery. So once we get the engine started and we turn the alternator on, we'll say the battery's somewhere around 25.2. We discharge it a little. So it's maybe 24.9. The alternator's at 20 volts. Whichever of these two components, the alternator or the battery, whichever one has the higher voltage, that is the component that is supplying power to the entire system. So not only is the alternator shoving electrons, pulling electrons out of the negative side of the positive side of the battery and shoving them into the negative side of the battery to charge it, it's now going to supply power to the rest of the components that are hooked up to the bus bar. So the alternator is still going to push electrons through that motor in the same direction as the battery would have, and it's also going to push electrons in the same direction through the light bulb. So if you don't talk about the battery and you talk about the entire rest of the system, it still does meet the definition of DC system. The electrons only travel in one direction. And still, this alternator, this is the negative side of the alternator, this is the positive side of the alternator. So it's actually taking electrons and shoving them through the light bulb to the bus bar and pulling them back down. So the bus bar is still positively charged and ground is still negative. The only difference here, I'm going to say it again, when you turn on the motor, the engine, and you turn on the alternator or generator, that alternator, if the alternator is working correctly, it's going to put out a higher voltage, or it's going to have a higher voltage. So now it's going to charge the battery. So now electrons are going to go through the battery in the opposite direction to charge it up. But everything else in the system is still going to have the electrons going through it in the same direction. Now light bulbs don't care. Light bulbs do not care which direction electrons go through them, not DC light bulbs. Can anybody think of a component that I could hook up to the bus bar that does care what. There are some LEDs, that is correct. But there's not a lot of LEDs on airplanes yet. It's getting more so. Radios. They are very, very sensitive about shoving electrons through them in the wrong direction. Has anybody ever hooked up a stereo in a car? Has anybody ever fried a stereo they were putting in a car by hooking it up backwards? Awesome. That's good. I've only done it once. Out of 17 different auto stereos that I've installed. So that's an A, right? 16 out of 17, that's like a 95, right? So does that mean I get an A for doing 16 out of 17 of them correctly? Radios are very sensitive. You hook them up backwards, it will fry them. So the good news here is in this DC system is that when the battery is providing the power, sure enough, electrons are going to go in this direction. But when we start the alternator, and the alternator is providing power, the electrons put out by the alternator are also going to push the electrons in the same direction through the radio. So again, all those components other than the battery, the electrons are going in the same direction. In fact, you could even say in the alternator, electrons only go in one direction as well. Okay, so now I have a little bit of an idea of what's going on inside of a basic DC system, including the battery and including the alternator. So now I want to talk about these two round gizmos up here. Which one of them I just erased? So both of them are ammeters, but usually this one is called a load meter. So on old school cars and in Cessnas, they put the ammeter hooked up in series with the battery. And when I say in series, that means every electron that's going through the battery, going to or from the battery, has to go through the ammeter. If electrons are going in this direction or they're coming down, either way, the electrons have to go through this ammeter no matter what. So let's think about, let's say the alternator is turned off and the battery is discharging. If the battery is discharging, these negative electrons, the red here is the battery discharging. The electrons are going to go through the ammeter, and this needle is going to point to the negative side. That means that the battery is discharging. So it might say minus 10, and it's labeled in amps. So if it says negative 10, so this is what would happen in that. And old school cars, before we had electronic displays, or now all you do is a lot of cars, all you do is you have a little red light that looks kind of like a battery. If the red light comes on, all it's really telling you, that's usually a voltmeter. That's just telling you the volts are usually something less than 12 volts. 11 and a half or 12, something below that, that battery light comes on. It's not telling you if the battery's no good. It's not telling you if the alternator's no good. It's just telling you the voltage in the system is no good. Of course, we think about it as the alternator light. In fact, I've seen old school cars where that light actually says ALT. Might be the alternator. In any case, there are some old school cars, and I've had a couple of them, where you actually had this kind of an ammeter. But but I'm not going to talk about cars. I'm going to talk about airplanes. You go out to this Cessna 210 out there. Well, let's take the 152 because it's a 28 volt system. It's older 172. I think this 210. I think this 210 is a 12 volt. So you're in the 152. You turn on the electrical master switch, and the battery gets hooked up to the bus bar, and you look at the ammeter. If you haven't turned anything on, what's running on the airplane? The rrr? Yeah. There's only one thing I can think of, a 152 that's running, even if you haven't turned on the electrical master switch, and that's the clock. But as soon as you turn it on, I master switch, didn't it start making noise? What thing that was spinning around? One of the gyros, the turn coordinator started. There's no switch for it. So if you went out to that airplane and turned on the master switch, let's just say that thing takes 1 amp. This will go over negative to negative 1 amp. The landing lights probably take 5 amps. If you turn on the landing lights, again, the engine's not running. If you turn on the landing lights, the engine's not running. The more things you turn on, farther to the negative this is going to be. Because the electrons are going to be going through all these gizmos. You turn on all the radios. And effectively, that means if the electrons are going in the direction to discharge the battery, then this is going to show a negative. If we start the engine, before the battery's dead, we start the engine and turn on the alternator, I bet you can start thinking of figuring out what's going to happen. If the alternator is producing power, it's shoving electrons into this direction and it's pulling them in this direction. So instead of the electrons going down, these electrons are going up, and yes, you are correct, this needle is going to show up on the positive side. Let's just say for fun that the battery is taking 10 amps to charge it right as soon as you start the engine. But we immediately turn on some lights and we turn on the radios. So say these lights take 2 amps and the radios take 8 amps. I'm making up some numbers. So this needle coming up here on the positive is going to sit there at 10 amps because the amperage coming out of the alternator going through these components don't go through this needle over here. They don't go through this gauge. As the battery gets charged, this needle will get closer and closer to 0, and it'll end up sitting somewhere at 1 to 2 amps, even when the battery's fully charged. So when the battery's fully charged, it'll still stay a little bit on the positive side. Which is a higher voltage, a fully charged battery or 28 volts, in this case, the alternator? Which is higher? The alternator. So the alternator is always going to be trying to pump a few electrons in there. And you're thinking, well, what happens to the energy? Really, all that happens is the battery gets a little warmer, which makes sense because we know when we push electrons through conductors, the conductor tends to get warmer. Maybe not a lot. So this is actually one way you can keep a battery from freezing in the winter, is hook it up to a battery charger. Because it'll always be trying to charge the battery a little bit, and the battery will stay just a little bit warm. So what I want you to get out of this gauge is that it only tells you what's going on with the battery. It's only hooked up in series with the battery. So it'll tell you if the battery is discharging, and it'll tell you if the battery is charging. And when it comes back to 1 or 2 on the positive side, that'll tell you the battery is now fully charged. So those are your 3 basic indications. If everything's working right, you'll only see it on the negative side when you turn on the electrical master and you don't start the engine, and you start turning electrical equipment on, you'll see the battery go more and more negative. When you start the engine, the battery will get charged by the alternator if everything's working right, and it'll come up to, it could go up to 15 amps if the battery's really close to being dead. Like if you just jumped it and you disconnect the jumper cables, man, that battery's really dead. That needle might come up to 15 or 20 amps, but it'll slowly come back towards 0, but it'll never quite get to 0. It'll always be at 1 or 2 amps because it's still trying to charge the battery. Okay, so that's what Cessna does. Piper and Beechcraft tend to have load meters. A load meter, you'll notice, that's also an ammeter, but it's hooked up with the alternator. So do you think this is going to tell us a lot about the battery, or do you think it's going to tell us a lot about the alternator? It's going to tell us a lot about the alternator. So literally, if the alternator's not working, let's say we turn on the electrical master switch and we're draining battery power, is if the alternator isn't turned on, we haven't even started the engine, is the alternator going to put out any amps or apply any voltage if we aren't even spinning it? I know this is tough. No, you got to spin it. So the needle in this thing is going to say 0. Let's pretend we start the engine, we turn on the alternator switch. Every electron that this alternator shoves out of it to either charge the battery or to go to the components has to go through this load meter. So when we turn on, it won't tell us if the battery is discharging while the alternator's off, but as soon as we turn on the alternator, with any luck, this alternator will come up to it'll come up to about 10 amps. And that's telling you that it's charging the battery. Electrons are getting pulled out of the positive side and they're getting shoved into the negative side. And this is going to tell you, as soon as you start the engine, how many amps used to charge the battery, plus anything else you've got turned on. But you probably haven't turned on very many things yet. But as soon as you turn on a light bulb or you turn on a radio, let's just say again, let's say the 10 amps is what the battery is using, but this motor takes 2 amps and these radios take 8, that's another 10. As soon as every time you turn one of these things on, the needle's going to come up. If we turn on both of those, it's going to be the battery plus everything turned on. But again, as the battery charges, maybe across 5 or 10 minutes, this needle's going to slowly come back down to whatever you got turned on plus 1 or 2 amps. So if you were going to look at this load meter and say, what's a normal set of indications? You'd say, I'm going to start the engine, I'm going to turn on the alternator, the needle will come up to whatever the battery is using to get charged and whatever I've got turned on. And over the next 5 or 10 minutes, as the battery charges, it's going to go down a little bit. As long as we notice that it goes down a little bit, we're going to go, okay. But when we turn on, let's say we turn on a 20 amp landing light, that needle's going to go up 20 amps higher than it was, and when we turn it, go down 20 amps lower than it was. So the load meter is telling you directly what is the alternator doing. You can guess what the battery is doing, but it tells you for sure what the alternator is doing. The ammeter in the battery circuit, it's telling you for sure what the battery is doing, but you can guess what the alternator is doing, because when it goes to positive, obviously it means the alternator is working. I'll see you all. I'll see a third of you in lab, and I don't know if Mr. Zoki's coming back for tomorrow. He told me on Friday he was still in deliberation on a court case, so class is dismissed.